Okay, number 8. B equals u minus z all over w. Number 10, G equals 10J. Let me give it a second or two for people to pull out their stuff. I don't know where Corbin is, but you know. Since y'all decided to be hyper punctual. Well, some of you.
I know number 22 is confusing. It's confusing for me.
You know that number 22 is confusing. All right. Okay, so where was I? Number 10 is G equals 10J plus 9H all over F. 12 is T equals 3/2 times, in parentheses, R minus V. 14 is A equals -3 plus X all over 10C. 16A, excuse me, is R equals capital C divided by 2 pi. And 16B is about 6 feet. 18 is 16.1 laps. 20 equals, N equals RT minus Q all over -10. 22 is A equals -Y minus Z all over X minus W. Hey, Corbin. 24 is about 24.5 miles per hour. Make sure you put units. 26 is about 5.0 feet per second. And 28A is R equals AP divided by 9. And 28B is 26 runs. What questions do we have on those? 12 and 22. Okay. Let's look at 12. So for 12, we have R equals 2/3 T plus V, and we're solving it for T. Okay. So, got to get all the junk off of the T. So what should we do? Subtract the V. Sounds great. So we've got R minus V equals 2/3 T. Excuse me. Now what do we need to do? Times 2/3 almost, but not quite. Because that 2/3 is multiplied. So how do we divide fractions? Because we've got to divide it. What do we have to multiply by? By the reciprocal. We've got to multiply by the reciprocal. So 3/2. The one tricky bit with this one, well, maybe there's a lot of tricky bits, but one of the tricky bits is you got to multiply everything times 3/2. So the way the answer key writes the answer is this, right? Halves times R minus V. But you could also go ahead and distribute that and write T equals 3/2 R minus 3/2 V. Oops, 3/2 V. So either one of these answers is a great answer. Either one of them would be fine. Okay? No. There's a video. You can watch it and whatever else. I'm not going to reread the things I already read. We were going to do 14 and which one did you say? 22. Okay. 22. All right. 22, ax plus z. Ax plus z equals AW minus y. And we're supposed to solve this? Yeah, I thought so. 4a. Okay, so we're going to kind of preview something a little bit, this one, which makes this problem a little bit tricky, right? We'll solve this for a. So what should our first goal be, you think? What do we think is probably our first goal in this problem? I agree. We should totally try to get the a's on the same side. So how would we move this one from over here to over there? Going to subtract the a. We're going to subtract, right? Because we're going to do the opposite. Does that make sense? You sure? Because you said add. I want to make sure you understand. Yes? Good. Minus AW minus AW. Now this isn't like terms with anything over here, right? So we just got to write it down next to everything, yeah? So we've got AX.
Why isn't it negative AW plus AX?
You could write it that way. You could write it in the front. Either way would be fine. Yeah. Plus Z equals negative Y. Okay, so now what do we need to do next? I agree, let's do that. So now, once we have that, we have everything that has an A in it, the one we're looking for, and everything that doesn't have an A on the other side, right? We've got kind of, it's split into groups. Okay, so now we have to figure out how to get to that A. So what we're going to do is something that we're kind of learning new right now. We're gonna practice it a bunch later, but we're gonna actually factor an A out. We're gonna pull an A out of everything. Okay? So the way that works is we're gonna write down an A and then a parentheses. And then we're going to write down what's left when we pull an A out. So what we're really doing, and on this problem, you don't necessarily have to know this, you just kind of have to, because you can probably do this one without that. But what we're really doing next is we're dividing by A on everything and writing down what's left. So what's left in this first term? What if we pull an A out of that first one, what's left? An X. And then in the second term, it's a minus W, or negative W, right? Equals Y minus Z. Excuse me. Okay. So now, remember we're still trying to solve for A, right? So how is all of that mess attached to A? Is it added, subtracted, multiplied, divided, or something else? Multiplied. So how do we get rid of it? Divide it. So we're going to divide both sides by X minus W. Okay, so then our final answer has got a G in it for some reason. Is A equals Y minus Z over X minus W. Does that make sense?
My cousin in college couldn't even figure that out.
I didn't understand any of the words you just said.
My cousin in college couldn't figure that out.
Your cousin in college couldn't figure it out, or your cousin in college must not know about math. What is your college cousin person's major? Business.
Definitely not.
Oh.
Math.
But does this make sense now that we've walked it out? Do you understand the bits? Okay. All right. What other questions from this homework set are we going to do?
I was not sure about 24, so
Sure, we can do it. 24. Select the appropriate unit from the choice below and convert the rate to that unit. Okay, so 24 is car traveling at 36 feet per second. Feet per second, right? So of feet per second, miles per hour, millimeters per second, or kilometers per second, which of those units makes sense for a car? Miles per hour, absolutely. If it would have been kilometers per hour, then it would have been a toss-up. But it says kilometers per second, and that's a little bit wonky, right? So definitely miles per hour. So we want to convert to miles per hour, right? Those of you who've had my class before, you know really well how I teach doing unit conversions, right? We're not where we want to be. We need to add something. What we need to add is a times fraction bar, right? Do we want feet? Yes or no? No. We want miles, so we don't want feet. So we need to cancel the feet. So in order to cancel the feet, where do we need to put the feet? On the top or the bottom? On the bottom. Now, do we know a conversion from feet to miles? Do we know how many feet are in a mile? 5,280. So the answer is yes, right? Yes, right? So we can put miles up there. The feet are going to cancel. Now, do we want seconds? No. So we need another times fraction bar, right? If we want to cancel the seconds, where do the seconds need to be?
On the top.
On the top. It's got to be the opposite of where it was. Do we know, we go into hours, do we know how many seconds are in an hour? No, that is true, 3,600, but let's pretend like you didn't know that. Because you didn't know what 60 times 60 was. So let's assume that you don't actually know how many seconds are in an hour, but you do know that there's 60 seconds in a minute, right? So let's go to minutes. You're not wrong, you're totally right. Good job, virtual high five. I lied, that was a real high five. What happened?
No, it's us.
Do we want minutes? No. So we need another times fraction bar.
I thought it meant just like choose one and write it down.
Same.
And then just write down those minutes, hours. Well, you didn't read all the words.
I didn't know that.
You didn't comprehend the word convert. How many feet are in a mile?
5,280.
80 in 1 mile. How many seconds in a minute?
50.
How many minutes in an hour?
60.
Which is where the 3,600 comes from, accurate. So now all you got to do is multiply on the top. So on your calculator, all you do have to do is 36 times 60 times 60 divided by 5,280, enter. And you'll get the answer.
Yeah.
Got 24.54.
Yeah, I got 24.4.
Okay. So 24.5 miles per hour.
I thought it meant choose one of those.
I know.
Well, it says to select one and convert. Because, you know, that's how English works. You have to read like all the words.
26 per second.
Was what?
Was 26 feet per second.
Feet per second, absolutely, would be a good choice. And then you'd have to do the conversion. Bro. Any other questions from this lesson? $16A, is that what you said? Okay, sure. The largest yo-yo in the world is 37.8 feet in circumference. The formula for circumference is C equals 2 pi r. Where C represents the circumference and R represents the radius. Solve the formula for R. So how are we going to solve for R? What's attached to R? 2 pi. How are they attached? Yeah, so how do we get rid of them? Divide. So R equals C over 2 pi. There, part A done.
Oh, wait. That's what I did.
Okay. Now for 16 part B, it says find the radius of the yo-yo. And it gives us that the circumference is 37.8. So what do we do now?
Multiply 2 pi out.
What?
Multiply 2 pi.
Oh yeah, sure. Yeah, that's fine. Now what do you do?
Divide this.
Yeah. So 37.8 divided by 2 pi is what? So about 6. What are the units? What are we doing? Feet.
I don't know how I got this.
Wait, did you get this?
Did you do the math right? Did you set it up right, Corbin?
No, I just.
The second part is the part that you said you didn't know how to get.
I got 44 feet.
Okay. So, but did you set it up like this?
I think so.
Okay. So and the reason I'm asking you this because I know what you did wrong. What you punched in your calculator was 37.8 divided by 2 pi, or 2 times pi, or something, right? So you've got to do this, because it's divided by that whole thing. So if you'll put parentheses in your calculator, it'll give it to you, the right answer. So that's what happened. Because what it did was this. Are you ready? It did 37.8 divided by 2 times pi, which would look like, if we were to rewrite this in like a more algebra way, it would look like 37.8 pi over 2. So you took the pi and you shoved it up on the top on accident.
You didn't do parentheses and you still got the right answer.
So his calculator figured out what he wanted.
Mine's smarter than yours.
Okay, good.
Why'd you delete? Why people? Children!
This plus this one, then I'll go back to the old.
I have smart.
No, you don't.
I got the same thing. So what did I do?
It's smart now.
Well, so do it right in the future. Use your brain before you type the buttons. Remember, that's like the rule. Where even is the pi button?
It's
You have to
below
press
the-
shift and then times 10x.
You give us like, when you got like video on that.
Hey, you should
On
know.
calculator.
Yeah. No, yeah, those.
I remember too, yeah.
It was my favorite one.
confused by how
It was my favorite one.
You probably, when you did it, you probably pushed times the first time. Because I bet if you push 2 times pi, then it's gonna give you a wrong number. Okay.
Okay, wait. 37.8 times 2 pi?
No. Okay. Any other questions on this lesson? Guys, quit playing with your calculators. And are there any more questions on this lesson? Okay. Let's take a quiz, and then we're going to do like what we've been doing, and we're going to do more math. Y'all are going to be so prepared for your next classes after this class. It's going to be great. What?
Oh, wait.
6 Z's.
Whoa. Or like a bunch of Z's.
Quiz. 2-8. Page 128. Numbers 1 and 3. That's what you said about 11 last time. The stuff I'm about about to talk about will not be on the test. It's Unit 3 material. So don't misunderstand and actually study how to graph lines, because that's not going to be on the test. However, do study for the test. Because if you don't, you're going to fail it. And we don't want that. Okay. Let's talk about graphs. Let's start with baby stuff, and we'll move up to more advanced stuff. We're gonna see how far we can push this Algebra 1 class this year. How does that sound, everybody? Real good? What is this? Right here. It is a really fancy plus sign. What else is it? A graphing thingy, that's right. So the official name for this is a Cartesian coordinate grid. You don't really have to know this. This is an XY plane, right? You got the x-axis, got the y-axis. X is the independent variable, Y is the dependent variable. We've seen all of that before, right? So we can graph all kinds of magical things on this.
Like faces.
We could graph faces. We could graph whirlies, whatever else. But we're going to focus for the majority of this class on just straight lines. We're going to we'll get to quadratics too, but not for a little while yet. That'll be later, much later in the year. Although if we do what?
If you do I looked at a graphing calculator, and it's like you do x plus 2 an absolute value, it's like
Yes, it is a V. We are going to talk about those this year too. Absolutely. Okay. So we're going to kind of do an example. And we're going to graph 3x minus 2y plus 4, no, not plus 4, equals 4, using the x and y intercepts. Okay. So let's talk about what that means. The x-intercept is where this line crosses the x-axis. No, it doesn't mean that at all. The y-intercept is where that line crosses the y-axis. So here's the deal. What is the very middle of this graph? It is 0, 0. It's where x equals 0 and y equals 0. That right there. That is the point 0, 0, right? Not an owl, even though that looks like an owl. Yeah. Okay. So that's 0. Now it also has another fancy name. Does anybody know what another fancy name for the middle is? No, different. What?
It's in the back of my brain somewhere.
It's called the origin. Origin. No, not aura. That's not even spelled the same. Okay. It's called the origin, right? So now here's my next question. So we need to find the x and y intercepts of this. So we need to use our little thinking brains, right? All along the x-axis, everywhere along here, what is y equal to? 0, because we didn't go up any, we didn't go down any, right? All along the y-axis, what is x equal to? 0, because we didn't go to the right any, we didn't go to the left any, right? So, to find the x-intercept, We need to plug a 0 in for y and then solve for x. You have something to add? Do you have something to add? Okay. Equals 4. So now we can solve that for x, right? What do we do to solve that for x? I agree. Y'all have any other ideas? Negative 2 times 0 sounds like a great place to start. Thank you for volunteering some thoughts. Good job. What's negative 2 times 0? Yeah, but you didn't. What's negative 2 times 0? 0. He poofs away. Gone. Right? Now what?
Divide 0.
Divide by what? 3.
No, just divide for no reason.
Divide by 0.
No, divide by x.
So the x-intercept is at 1 1/3, right? So on our graph, we can go over, we can have 1 and 2 and 3, and we can put a dot at 1 1/3. Right there. Making sense so far? Easy peasy? Good. What about the y-intercept? How are we going to find the y-intercept? Same thing, but what?
Y.
But what's going to change? Yes, ma'am?
X is going to be 0, so we can't.
That's right. That's right. The x is going to be 0 this time. So that cancels out. And then we've got negative 2y equals 4. And then we divide by negative 2. And we've got y equals negative 2. So the y-intercept is at y equals 2.
I'm gonna go down.
Oh, yeah, you're right. Negative 2. Thank you. I was about to make a mistake.
You're welcome.
And then, to graph it, all we got to do is connect the dots and draw a line. Because it's a habit. It just, unfortunately for us, it happens to be an annoying habit. But I don't think that Gavin is doing it to annoy us. I think it just happens. Look at that. Easy peasy. Now here's something important that I want you to stick in your brain for later. Yeah. Even if the equation for whatever we're graphing looks like this, even if it looks like that, to find the x and y intercepts, it's the same process. To find the x-intercept, we put a 0 here and then solve. Now that part, you have to know some more things to solve, right? But to find the y-intercept, you put a 0 in for x and then solve. So like this one, the y-intercept would be real easy because we put a 0 and go, it's 2. Right? The y-intercept of this ugly thing would be at 2, and y'all could do that today. So the point I'm making is to find the x and y-intercepts, you just put 0 in for the opposite one and then solve. Okay? Easy money?
Easy money.
Good. Let's learn something else.
Yeah.
You know what would be really cool? And if we keep doing stuff like this, it would be possible. This would be the first year where this would be possible. You know what would be really cool is if this year we were, no, that's well, maybe. It would be cool if we got all the way to chapter 11 in this book, maybe even 12.
I only have 10 tabs. You told me to buy 10.
I know, because it's not normal. So in most math books, you should know that at a certain point, there's a bunch of beginning chapters that are like review, and it's like new stuff, and then it's like extension stuff. That's how math books work. It'd be really cool if we got like way in there. Then y'all be doing stuff that's like in Algebra 2 and whatever else. Think about how smart and prepared y'all would be. Then new students come into my class with y'all would be like, wait, what? How do you know how to do this? Okay, let's talk about lines a little bit more. So, in basic, simple baby terms, what does linear mean?
Line.
Makes a line, yeah. In basic, simple baby terms, linear means makes a line, right? Easy money, yeah? Right? No big deal. Basic, simple baby terms, makes a line, straight line. Linear, 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 more linear, right? It's all linear. Great, easy money. Why? Are you being grumpy pantsed? Are your pants grumpy today? Change your pants. Okay. Okay. That's something I learned in teacher school with Mr. What's his name? Christian, maybe? Mr. Christian? I don't know. That's Rochelle would be able to remember. He said in Foundations of Education, that was one of the first things he taught us. He said, you know, some days you're going to have a bad day. And some days you're going to, the laundry's going to blow up and whatever else, you're going to go to teach. And you're not going to be in a good attitude. He said, but here's a secret for you. You can go to the personality store and buy yourself a new one and then put on that personality and then teach as if you weren't having a bad day. You get to choose your attitude. Change your pants. Okay, now, so linear function makes a line, right? Easy money. So, I'm going to write some equations up here. Okay. Oh, I accidentally wrote the same one twice. Yay, good job.
If you and Sean read a full script, it's a terrible idea.
What else do we want? How about this one? Okay. There's a bunch of functions up on the board, or possibly functions, definitely relations, right? Which ones are linear? Or which ones are not linear? No, they're not all linear. That's a thoughtful guess, but no, they're definitely not linear.
Maybe the square root one is linear.
This is not linear. That's true. This one is not linear. If I was to graph that, it would look like this, which you'll learn later. It's not linear. Okay. What else is not linear? Y over x is not linear. That's true. That's not linear because x is in the denominator.
Y less
Which one?
Y equals.
X squared is not linear. Absolutely.
Y equals 1 over x.
That's not linear because we've got the x in the denominator. That's not linear because it's the same as that. So what about these two? Are these linear?
Y equals x minus 2.
It is linear. This is definitely linear. What about this one? Is this linear?
Yes.
It is also linear. Okay, so here, let's see if we can figure out the main key difference between the ones that are not and the ones that are.
What about y less?
Oh yeah, that's right. What about that one? Is that linear?
Yeah.
Yes,
Yeah?
it is. Yes and no. Yes, no. No, yes, no, yes.
It is linear. It is linear. It is definitely linear. Okay. But why? Right there. No. But why is that linear? Okay, so it's right there.
Exactly.
If only you were funny. Okay.
Sure.
This one has x squared. Now, this is something you're going to learn a lot later, but this is just kind of, you can't have an x in the denominator and be linear. And the reason why you can't have that is because if I could convert this and it would turn into y equals x to the negative 1, but you don't have to know that. All you have to know for today is you can't have an x in the denominator and be linear, right? But that, I'm giving you that a clue. This one also here, if we take this one, we could also convert this one to y equals x to the 1/2. That's problematic. You don't have to know that, but you do have to know that you can't have x inside a square root. And here's the thing, are you ready? This has got an x squared in it, which is square. 2 is not 1. Did y'all know that? Wow. 2 is not 1. 1/2 is not 1, and negative 1 is not 1. So as long as the biggest power of x you have is to the first, it's linear. So this one, it's got x to the first, x to the first, x to the first. So it works out just great. And they're all linear. As long as the biggest x is x to the first, it's linear. The y, yeah, the y has to be to the first two. But it's going to be a long, long time before you deal with anything where the y isn't just y. That exists, but we have to get to conics before we can even talk about that. Because it's crybaby, I don't know. Okay. So there are a couple of different ways that you can write, a couple of different generic ways that we can write the equation of a line. First one is standard form. Which is the most useless and the most formal. And the second one that we're going to talk about that's really important and very helpful is called the slope-intercept form.
Sorry.
Man, never considered myself that scary.
Okay. Okay. Standard form looks like this. AX plus BY equals C. Yeah, Pikachu. That's right. Okay. Now, in order for it to be standard form, A, B, and C must be integers. And A must be positive. Okay. So, what does the fact they have to be integers mean? What can they not be? Yeah, so they can't be irrational numbers like pi. They also can't be rational numbers like 1/2 or 3/4 or 5/32, right? They have to be whole numbers. They can be negative, but A has to be positive to be in standard form. Now this guy is much more useful. This one, if we're looking at an equation that's in standard form, it tells us nothing. Nothing at all. Nada. Okay? So it's useless, but it's formal. Yes, ma'am?
Is slope-intercept form the m equals?
Yes, it is. The slope-intercept form is y equals m, oh no, it's a new letter, x plus b. The slope-intercept form is very useful, very handy, very fun, very awesome. He put on his happy pants today. Okay? Because now, x and y are just x and y. They're letters. They're the variables that say that when we get finished and we have something in slope-intercept form, it's going to have a y in it, it's going to have an x in it. It's going to be kind of like that blue one I wrote earlier, but solved for y. Right? But the m and the b are things that are helpful. Based on the name, what do you think they are? The slope and intercept. Specifically the y-intercept. Okay? M is the slope. And B is the y-intercept. Okay. Now, what is the y-intercept? We just talked about that. What does that mean?
Like the line goes on the y.
Yeah, so where the line crosses that y-axis. Okay? So that's what it is. Where it crosses the y-axis. Okay. What is the slope? What? Yeah. So, where else have you heard the word slope out in the world?
Oh, it's like the slide slope.
Yeah, slide slope, the slope of the mountain, right? I know we don't have any of those anywhere near here, but right? So the slope is how steep it is, right? How steep it is. It's got other names like rate of change and whatever else, which we'll learn all that, but for the sake of discussion right now, that's what the slope is. Make sense so far? Everybody got this copied down? Can I erase this? Okay. Is that how you feel about it? The slope. We're going to break slope down a little bit. The slope.
I think you should
So,
That's mine.
you're all good? Y'all, I said, plural. What letter did we just assign to slope? M. Slope is M. It's also the rate of change. So, what does the word rate mean? What's something that's a rate in the world?
Rated.
No, not that rate. Not rating, but rate by itself. Not rating, not going with rating. But if I said rate and it had to do with cars,
red rate.
quit trying to be clever because you're failing at it, and listen and answer the question.
You could say like the amount, like amount almost.
Kind of. We're getting closer. So the rate is like how fast. My rate when I'm driving could be 38 miles per hour, right?
Or like the.
So rate of change is how fast something's changing, right? That's what it is. So the rate of change, now there is a mnemonic that can help us remember what slope is. Slope is rise over run.
I remember that.
Okay? And we know it's rise over run because you have to rise before you can run, right? So it's rise over run. So rise would be up and down, right? Which one is that? The Y's or the X's? Y's. And run would be left and right. So we've got up and down over left and right. Okay? So it's the difference of the y's. Now we're going to use that fancy subscript thing that we've learned recently, right? So it's the difference of the y's, y2 minus y1 over x2 minus x1.
I learned that like 2 weeks ago.
Nice. Okay. Now I'm going to add, because we're pushing ahead, I'm going to even add some big brain a sort of notation on here. When we have a change in, we get to use a fancy Greek letter.
Oh no.
Okay? We get to use
The triangles.
this letter. This is a Greek letter delta. I already told you to stop trying to be clever because you're failing at it. Okay. That's delta. And what it means in math and science is change in. So this is the change in the y's over the changes in the x's. So we could simplify this to delta y over delta x. Now, if we want to take all of this and we want to extract a formula that's going to be useful for finding the slope given 2 points, we can extract this and write the slope formula. You did not. That's lies.
You must not tell us.
So this is the slope formula. You did somewhere in your head. We talked about it last year.
And the year before that.
It's possibly true. I don't know.
I remember, maybe not the slope formula, but I remember delta.
Nice. Okay. Everybody got this down? Okay. Let's do an example or two using the slope formula, and then I'm going to let you leave. Make like a tree and get out of here.
I did change. It makes so neat.
Find the slope between the points A, -2, 5, and B, 3, -12. What's the slope formula?
Y2 minus Y1.
Yeah, difference of the y's over the difference of the x's. So what we're going to do is put parentheses and then substitute in what we have. I find it can be, is there a reason you're putting up before I said leave? You're going to walk in late and put up early? Let's not do that ever again, either one of them. I mean, unless you're like mom is running late and you can't help the late part. That would not be on you. Okay. I find it can be helpful to label X1 and Y1 and all of this stuff up on those letters. Right? So points go YX or XY? They go XY. So this could be X1, which would make this what? No, yeah, Y1. If that's X1, that's got to be Y1, right? So this would be X2, and this would be Y2, right? I find that to be kind of useful. You don't necessarily always and forever have to label them, but when you're first kind of learning, it can be useful, right? So what are we going to put right here? -12.
Oh yeah, I was.
And what are we going to put right here?
5.
5. And this one?
Three.
3, right? And negative 2. Now, we've got a minus, so what do we got to do with that? We ka-chink that, right? So, negative 12. Put your calculator away. You don't need it. Negative 12 minus 5. Are the sides the same or different? Same. So, do we add or subtract? Add and keep the sign. So, what's negative 12 plus negative 5? Negative 17. And then 3 plus 2 is what? 5. Now, when we're doing slope, we don't want an improper fraction. We don't want a decimal. We want, I said improper, I meant mixed number. We don't want a mixed number because we want rise over run when we're graphing it, which we'll see later when we get to that. Make sense? Okay, ladies and gentlemen. We have a test on Tuesday over chapter 2. None of this stuff that we just talked about will be on the test. However, all the stuff from practice tests and all the things from chapter 2 will be on the test. So study. I'll see most of you on Tuesday.